Well, hello everybody, and hopefully you're joining us today for this webinar. And so before I really get started in today's webinar, I want to do a little bit of some housekeeping things so that you kind of, as you're strolling in here or as you're starting to participate in the program, that you will get a little bit of an understanding of how this is going to go. Again, you might see me looking up. That's because the camera is up there. And so I tend to look at my information on my screen and then I talk, so I might not look right at the camera. When I want something, I will look at the camera, and you know that I'll be directing it to you. There is a slight delay. You won't know any different on your end, but I do on my end, so sometimes it might get me a little bit of a hiccup here because I'm, a delay. So today's class, I guess I should show you, before we even get started, I just wanted to show you that you can join and log in and ask questions, although I won't look at them very often, save them usually to the end because I want to spend most of that hour doing our education because it's going to take me at least that long. Everybody knows I'm fairly long-winded. So I need that, but just in case you don't know, when you go to the webinar link on our website, you'll see where you can actually, if you have trouble viewing this, and you wouldn't see this if you were, then you can click on the YouTube link as a direct feed, and that will take you directly to the YouTube channel, and it might stream for you a little bit better there. That will be available on all future webinars as well. Okay, below the actual video, you'll see a chat box, and you're more than happy to type in a question that you might have down there, and I'll answer that question as I get to it. If we get a break or we get going pretty quickly, then I might be able to go down and look at some, but usually I'll save them to the end. So just keep piling them up, and I get to the end, I'll ask your question, or I'll answer your question, if you will, the best I can do it. All right, so today we're going to talk single family dwellings. So we're also talking about the individual dwelling units for a multifamily building, but we're talking about the individual dwelling unit or the one family dwelling itself. Now today we're talking about the standard method. Okay, we're not talking optional method. So purely standard. Now, a lot of people say, well, I can do the optional method. It's going to result in a smaller service. Why in the world would I ever want to know how to do the standard method? Well, if you're taking an exam, more often than not, the standard method is what they're going to use on the exam. Okay, if they tell you to use the optional method, you just need to know the optional method. And I really teach you both in the academy. And again, if you've never been to our website, you got that ticker going on right here. Please, obviously you've been there because you're here for the webinar. But we have a lot of videos on YouTube and all kinds of topics that you can watch. We even have our ultimate guide. Now, today's course is based on the information that comes out of our ultimate guide to the NEC. So it is based on that illustrated guide that's published by Cengage and Charles Miller. So it's part of what we teach in our Master the NEC program and the Ultimate Guide program. It's also available in the Fast Tracks as well. Okay, so today we're going to base all that on that information that we have. Okay, so let's kind of get into the presentation a little bit and get started. All right, so here you'll see the presentation. We're going to start again, single family dwellings, and you'll see me here, and I'll help you out along the way as we talk about single family dwellings and how we apply to these types of single family dwellings. Okay. All right. First things first, a lot of people say, look, I don't always get drawings for a single family dwelling. That's true, but there usually is some kind of building set or architectural drawing or something that can give me the dimensions that we need in order to be able to get started. Now, granted, most one-family dwellings and dwelling units, well, I guess a dwelling unit and a multifamily is going to probably have drawings. But in our case, single family, you're really probably not going to get any drawings, but you might get a blueprint. Maybe it's the builder's blueprint. These are going to give you some dimensions that you can work on, okay? So where do we begin? It sometimes can be confusing for people because of all the little sections that are in the NEC. And today we're going to focus on Article 220. And we're going to be in the 2017 edition of the National Electrical Code. Now, that doesn't mean if you're in the 14 that you're going to get lost. You're not, because there wasn't any significant changes that would cause any issues. But we're just kind of talking about what edition that we're going to be in, and that's going to be in the 2017 edition. Okay? All right, so first thing, I guess, first is we need to see what is involved in our building. And that's really the first thing is, what do I have? Now, sadly, the electrician doesn't always get all this information that we got right here. Okay, you don't really know yet what the dishwasher is. You don't yet know the trash compactor. Now, you know you got to run circuits for it because you're laying all this stuff out. But you really don't know all the details. And you really kind of do, especially when you're sizing the branch circuit for all these things. So we have the luxury of knowing what our loads are going to be. And we have to do some calculations. But again, remember, it's, that's why electricians, it's a very highly skilled profession. Because we have to work intimately with the designers, the homeowners, to try to get all the information that we can get in order to be able to do a calculation, okay? And we're using the standard method. And also, there's another reason why we learn the standard method as well as the optional, is that when we're doing an optional method, which is always going to result in a smaller service or smaller feeder, when applicable, is that we have to remember that when you size the neutral or the grounded conductor, we can't do that versus using the neutral, the optional calculation. We have to use the standard. So you got to learn how to do the standard calculation and be able to understand that if you use an optional, that I still need to use the standard in order to get my neutral or grounded conductor calculation. Okay. Now, I understand that a lot of people today just go, well, look, whatever my calculated size is for my ungrounded service conductors, I'm just going to make the grounded neutral conductor the same size. I don't want to have to do any additional math. Okay, that probably gets done. But in many cases, you buy SEU, Service Entrance Type U. It's going to come with a reduced size grounded conductor, or neutral in this case. So you just kind of have to understand it. And I prefer you understand how to calculate all that out. Okay. So as we see here, we've got a 35 foot by 55 foot outside dimension, and we're going to look at all that here in a second. We've got a front porch that's actually included in the outside dimensions, but that front porch dimension is 7 by 10. We're going to need to know that later. Let's see here. We've got the 4, that is 4 small appliance branch circuits. Of course, remembering that the National Electrical Code under 210.11c is only going to require at least 2. But if you're on an exam or in the real world, you've got more than 2, then you need to account for those. Okay, so remember that. Small appliance branch circuit, we've got 4. Laundry branch circuit. The code again in 210.11c says that I only have to have 1, a minimum of at least 1. But if your calculation has 2, such as ours, then I'm going to have to count for both of those. We have a water heater, which is 45 kW. Also remember, like it says up here, in our calculating for loads, we're going to assume kW is equivalent to kVA. So watts would be equivalent to VA. Okay, so it's 4.5 kW. To translate that into watts, the K here, so it's 4.5 times 1,000. It's going to be 4,500. Dishwasher, 10 amperes. We kind of given it to you right off the bat. And this is a combination load, means it's usually got some kind of motor, which is a smaller motor, and then it's got some kind of heating element. And that's where the majority of the resistance heating load is going to come from. That's why we're not going to count that really as the largest motor later on. Okay, but the reason I mention that is because you could have other motors that are in conjunction with other pieces of appliances or equipment that might be a rather large motor, and it might have to be taken into consideration when you're doing the largest motor. But we'll talk about that later. In-sink waste disposer, half horsepower at 115 volts. Trash compactor, purely a motor load, just moves a pactor that actually crushes down in your waste that's in your trash compactor. Again, that's 7.5 amperes at 120 volts. We have 3 attic fans, very much our appliances, at 4.2 amperes each. Okay, so we're just adding all those together, and that's how we got the 12.6 amperes. And again, it's 120 volts. Clothes dryer, we have a 5.5 kW at 240 volts. We have a counter-mounted cooking unit at 7 kW, 240 volts. We have a wall-mounted oven at 6 kW. Okay, that's at 240 volts. We have electric heat, 3 banks at 5 kW each. That is total of 15 kW for our calculation at 240 volts. We have an air handler blower motor at 3.2 amperes at 115 volts, and a little tip up front that whether or not you're dealing with the heat or you're dealing with the AC, you're still going to have that blower motor that has to get added to it, because whether you're using the heat or the AC, the blower motor still got to move that air, right? Okay, just a kind of tip for later. We have an air conditioner compressor, okay? and that is 16.6 amperes at 230 volts. And we have a condenser fan motor at 2 amperes and 115 volts. Okay, so we'll refer to each one of these as we go, so you don't have to actually write them all down. We'll come back and look at each one of these specific things. Okay. All right, let's start off first. What do we do first? Well, in table 220.12, the general lighting loads are listed according to the type of occupancy and are determined by requiring a minimum lighting load for each square foot of floor area. Okay, so while we're doing this, we might as well go on and look at the code book and kind of go over what we're talking about right here. So it kind of gets us going, and it says, okay, well, we have lighting loads for specified occupancies. It says a unit load is not less than specified in table 220.12 for occupancy specified shall constitute the minimum lighting load. Okay, we're going to start with the lighting load, obviously, here. Okay, the floor area of each floor shall be calculated from the outside dimensions of the building. All right, now ours, we're going to say ours is just one floor. Okay, make it simple, one floor. All right, and it says for dwelling units, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use. Okay, so what are we talking about? So in those applications where we have not adaptable for future use means an attic. If the attic itself has, you know what? I need to check something real quick, guys, to make sure that I am not going in and out of focus. Sorry about that. If you have an attic and it's not adaptable for future use, then I'm not going to count that square footage. But if I have a basement and that basement is unfinished, but it could be finished off later, then that is adaptable for future use, and that is something that we're going to use. Okay, so that's kind of how it works. Now, the open porch in our example, that 7 by 10 foot porch, okay, that's going to get subtracted away from our value. Okay, so we're going to go look at that and see how that calculation works out. Oh, I guess before we even do that, we need to go and see what did it say about the table 220.12, because we need to determine a VA to use. Okay, so we're going to go back to the code book, and it sends us down to table 220.12. So we're going to scroll on down to 220.12. Here we go, dealing with the general lighting by occupancy. So here's a dwelling unit. And the dwelling unit is going to use 3 VA per square foot. So that's the value we're going to use. Now you see this little A right here? Now all that A is here to do is to remind you of something. The A, if you come down here, tells us to see 220.14J. And that is over here. And that is the application where it says, look, all of those general use receptacles are all included in the calculation. Okay? So what it's saying is, in the bedroom, all those general receptacles, all of those in the den, all of those in the living room, I don't have to figure in anything else. So what you probably learned by now, that when you're dealing with a dwelling unit, the actual general lighting also includes the general receptacle application, okay, by virtue of 220.14J. And it's figured in there already in that 3 VA per square foot, okay? Now, if you have anything that's not covered under J or 220.14J that's outside of those listed that's included, then you have to account for those loads, okay? But here we're talking the receptacles are encompassed, the general use receptacles. Now, not the small appliance and not the laundry, okay? Those we're going to have to worry about in a second, okay? But anything else is incorporated in it. What about that bathroom circuit, okay? That's required by 210.11. Yeah, well, that is actually incorporated into 3VA. So I'm not only figuring my lighting, but I'm also figuring my general use receptacle as well in the calculation. So let's go back and look. All right, so here's what we did. We determined it was 3VA. And then, of course, we're dealing with that outside dimension. Is always want to use the outside dimension, 35 by 55. Some people ask me, what if I have kind of a broken up and it's not perfectly square or rectangle and I can't get a perfect dimension? Well, I usually tell people take the most furthest out of the building and act like you're overlaying a square. Do those dimensions, and then you can go in and take out the parts that jet back in, and you just kind of section out those pieces and subtract those, kind of like what we're doing right here for the front porch. So that 35 by 55 was like an overlaid rectangle, but there in that rectangle, there's a small area for the porch that needs to be taken out because it wasn't permitted to be calculated in there per 220.12. So we have to come up with those actual square feet area. So 35 by 55 is 1,925 square feet, and we have to take away that porch area, and that was 7 by 10 feet. So it's 7 times 10 equals 70 square feet. So literally, we're just taking the 1925, and we're taking away the 70, and that gives me 1,855. Now, what do we do with it now? Remember that 3 VA per square foot? We take that 1855 times 3 VA. That's going to give us the 5,565 VA. Okay? That's what we're going to get for. So that's our general lighting and receptacle load. All right, that's what we got for that. So you're going to write that down because that's your first number you're going to need to do the ultimate demand calculation for general lighting and receptacles and all that and small appliance and laundry. So write that down. So we're at 5,565. All right, so let's go to the next one. All right, we just clarify. We took care of this right here. So now we're moving on to these small appliance and this laundry brand circuit. Okay, so let's go on to that. All right, now. The small appliance brand circuit must be included when calculating a dwelling unit service per 220.52a. Okay, so we're going to go to the code and make sure we follow along in our code book. And we're going to go down to now we're getting into the actual calculation for the calculating of the dwelling unit under part 3. All right, so 220.52, here's our small appliance. And note that it says, let me make sure that I'm on that. It says each dwelling unit, the load shall be calculated at 1,500 VA for each 2-wire small appliance brand circuit as covered in 210.11c1. That's where it requires you to have at least 2. Now, in our scenario, how many do we have? Well, in our scenario, we've got 4 of them, as you see here on the screen. So we have to account for 1,500 VA for all 4 of those. Okay, so as you see here, it's simply take the 1,500 VA times 4 equals 6,000 VA. Now, you write that down because that's now your second step. Okay, we're still under the basic first step. We haven't applied any demand factors yet. We're simply starting to calculate our loads out. Okay, so that's our small appliance load. All right, what's next? The next would be the laundry. Now, in that laundry, you see that we had 2. Now, the code requires you to have at least 1. Now, there are some rules, and we're dealing with the dwelling units, single-family dwellings. Now, when you're dealing with multifamily and things like that, you might have it where you don't have a laundry circuit because you might have a laundry on facility. And we'll cover that when we do a multifamily calculation. But here in a single family, you're going to calculate at least 1 laundry circuit, okay? And that's going to be covering things like the washing machine and any additional receptacles that are on that same circuit, but no other outlets except those are dedicated to the laundry circuit can be on that. Okay, so you have to have at least 1 laundry brand circuit, and that's required by 210.11c2. All right. And again, another note is the load can be included in the general lighting load and subject to the demand factors. That's why we're adding them together. So what did we have up to this point? Let's kind of recap. We had 5,565. That was our general lighting and general receptacle. We had our small appliance branch circuits, and that gave us that 6,000 that we're dealing with. Then we had the laundry branch circuit, and that's given us our 3,000 because it was 1,500 VA. There was 2 of them, so that's 3,000. So now we get to say, well, what do we do next? Well, we take all of those and we compile them together. And what we've got is the general lighting and receptacle load. That was 5,565. That was the first step we did. Then we have the 6,000 for the small appliance branch circuit. Okay, we have that. And then we have the 3,000, which was the 2 laundry. We have that. Now, this is where we can say, now I get to apply some demand factors. And how do I do that? And how do I know that I can do these demand factors? Well, it tells us that we can do that under 220.42. And again, the general lighting, we get the permission to use table 220.42 to apply these demand factors under the standard method. Okay. Now, as I explained earlier, 220.14J, that means all those general use receptacles are incorporated in this value right here. This is the small appliance. This is the laundry. All those receptacles that are around your bedroom, your living room, all that gets fixed in. There's enough diversification in here as well as the general lighting that goes in here. Okay. All included in a dwelling unit. Now, when we do commercials or non-residential and commercial applications, you're going to see there's other lighting that gets added in and things like that, but usually not the case when you're doing a simple residential type of one-family dwelling calculation. It's about as difficult as it gets. All right, so let's see how we can apply these demands, okay, to be able to kind of work it out from here. All right, so we added all these up. So right here, it's 5565. We add the 6,000 for the small appliance. We add the 3,000 for the laundry. And what does the demand factor table tell us to do? Well, for dwelling units, it says, okay, the first 3,000 at 100%, and then from 3,001 to 120,000 at 35%. And of course, we're not going to come anywhere near needing the over 120,000 aspect and use 25%. So in normal dwellings that you might get on your simple exam, these are where you're going to pretty much be held to. So we did that. So here's how I like to explain it to people. I like to say take the first 3,000 at 100 and then the next 117,000 at 35%. It just makes it easier to remember because this one is from 301 to 120,000. So I'm taking away the 3,000 to be able to use the next 117,000 at 35%. So here's how I explain it. I take the total value, we added all those up, 14,565. Take the 3,000 away, set it aside, you're going to add it back later. And that would be 11,565 times 35%, because that's the amount that is over 3,000. And that gives me 4,047.75. Okay. Now, I can take, at this point, I would use the 0.5. That allows me to round in accordance with 220.5B of the NEC when we're doing a load calc. And so I would round this up to 4,048. Okay. Now, you could actually take this calculation exactly, 4,047.75, and add that 3,000 back into it, and you'd get 7,047.75. You're still going to do that rounding, and it's going to take you up to 7,048, however you want to do it. You could just take the 4,048 and add it to the 3. At the end, you're going to get the same result. Now, what do we have here? This is the first hardcore thing that you write on your calculation. The total general lighting and receptacle load is 7,048, and you write that down. Now you can forget all those other loads. This is your load you're using for the general lighting and receptacle load, total. All right, so we've covered all those here. Now we're moving on to the appliances. In terms of appliances, they're designated utilization equipment commonly built in standardized types and sizes and installed as a unit to perform specific functions. Now this is all defined in Article 100. Okay, so there's nothing new here. Okay, the dishwasher, for example, the disposer, all those are designed uniformly. They're all very similar. Okay, also remember that in our load calculations, if I have something that's in kW, like a water heater, that it's also considered also VA. In this case, kW would be kVA, but the watts would also be synonymous with VA. Okay, they work interchangeably when we're doing a load calculation. Okay. Now, a couple tips up front. Any of the appliances that are pure motors and they give you, let's say, a horsepower rating, then I usually tell people right off the bat, you need to go into the back of the book under table 430.248, because we're dealing with single phase right now. It's a single family dwelling. And that's going to give you the actual full load current. And that's what we need, okay, when we're doing these calculations, because I need to convert it into VA. I got to calculate everything into VA. Now, if you're lucky enough on an exam, they give you the amps and the voltage, then you can just calculate it. But in our case, a lot of times they give you the horsepower, and so we have to go back to 430.248 in order to be able to do that. And once we get that amp value from there, then we can multiply it by the voltage, and that's going to give us our VA. Another thing to remember, that if we have appliances and we have four or more, then we get to apply an additional D rating of 75%. But if I only got 1, 2, or 3 in our dwelling, then I got to take them as their full value. I don't get any discount, if you will. Okay. Again, the tip would be multiply the voltage by the ampere. That's going to give you the volt amperes. And we need to convert everything into volt amperes when we're doing these calculations. All right, so here's all of the appliances that we had. Now, here's the water heater, 4,500. We converted that by 45 times 1,000. That's 4,500 kilowatts. Or actually, you know what? That's wrong. It's 4,500 watts. And to convert that, you do this, and that's how you get the 4,500 VA. Dishwasher, 10 amps times 120. That was actually given to us. That's 1,200 VA. The in-sink waste disposer, it was a half horsepower. So how do we find that? Well, we had to go to table 430.248 under the 115 volt column, come down, and that's where we got the 9.8 amperes. Okay. And so then once we have the ampere rating, then we can take that times the voltage, and that's going to give us our VA. The trash compactor, 7.5 times 120 volts, that's going to give us 90 VA. Again, the first thing I would do on an exam is take all of these appliances, any motors that I have for the AC, and start to convert them to VA right away, okay? Because I'm going to need that information, okay? If you're doing this in the real world, it's the same way. There's no way you can calculate it unless you do that, because that's what we want to do. All right, so now that we've done all the appliances and worked them out, and you notice down here I had 3 attic fans where they're 4.2 amps each. I just did that times 3, and that's how I came up with the 12.6 amps. So 12.6 amps times 120 volts, because that's what's given to us on the question. That is 1,512 VA. So we add those together, 4,500, 1,200, 1,127, and 900, and 1,512. That gives us 9,239 VA. Now, how many appliances do I have? Okay, 5, right? No, actually, I've got more than 5. It was 1, 2, 3, 4, 5, 6, 7. But in their case, it didn't matter because we at least had 4 or more. But that might be something that could fool you on an exam. If you didn't have 1 or 2 of these others and you didn't calculate these as 3 of them, then you might get fooled and not think I have 3 appliances. Okay, but in our case, we did. Okay, all we did was combine the actual values here for the 3 attic fans because for simplification. All right, now since I have 75, what tells me in the code now for these appliances? Can I apply the 75%? All right, well that's 220.53, and so let's go on and look at that in the code book so that we can quantify it. And okay, so you kind of see how we go here. Some people like to put little notices down here, step 2, step 3, whatever you want to do. And here we're at the appliance loads. And it's a dwelling unit. And it says it shall be permissible to apply a demand factor of 75% to the nameplate rated low current of 4 or more appliances fastened in place. All right. And other than ranges, clothes dryers, space heating, air conditioning unit, or whatnot. Okay. So in our case, that gives us the permission to apply the 75%. So thus we have done that. And we took the 9,239 times 75%, and that was 6,929.25. Of course, that glorious 220.5b says that we can drop that 0.25, really simplify it, and that makes it 6,929 VA. Okay, so that is our value for the fastened in place. Now that is a value we're going to write down. Again, remember we wrote this value down. That was after we had to do all those little things for the general lighting, small appliance, laundry. That is our hard line that we write down to the side. That's a hard number that we got to write down. And of course, this is our next one, hard number we got to write down, 6,929 VA. Write that down. All right. Now let's tackle that clothes dryer that was in our calculation. That clothes dryer was 5.5 kW. Again, me and you both by now know that that's synonymous with 5.5 kVA. Or I can convert it out at 5.5 times 1,000, and now I have 5,500 watts. Or for what we need to use it for, we need it to be VA. So it's simply synonymous. The watts are synonymous with VA. So it's 5,500 VA. Now you'll see later, this is a neutral load consideration, and we're going to be able to use 70% of this value, but we'll talk about that when we get to the neutral. All right. So another thing to remember is that 220.54 says that in a clothes dryer is 5,000 watts or whatever, if it's larger, you take the larger. But it, at least for the standard method, is 5,000 watts, okay? And that's under 220.54, okay? So if we go to the code and we look at that, under 220.54, you see right here, and it said it shall be either 5,000 watts, and that's synonymous with volt amps, as you see here, or the nameplate rating, whichever is larger. All right, and in our case, the 5,500 is larger, so we're going to use that, okay? All right, so 5.5 kW equals 5,500 watts, volt amperes. Simplify it, 5.5 times 1,000, again, is 5,500 VA. So what is our dryer load? 5,500 VA. That's another hard number that we write down, okay? Now, if this was an optional method, we're using the nameplate, okay? In this case, it still would have been 5,500. But in the standard method, we're at least at 5,000 or the nameplate, whichever is larger, okay? Now, one thing to remember, that a dryer is not a required load, okay? If it's in your calculation, of course you add it. But nobody requires a dryer. Same as nobody requires cooking in your load calculation. But if it's there, you got to calculate for it. But it's not a required. It's not like the small appliances in the laundry circuit that's required, things like that. It's different. It's not required. But most of the times on a calculation, it's going to be in there because most dwelling units have a dryer. Okay, but that's the reason you have to know. And if you're taking an exam, just answer what they give you. If they don't give you a dryer, don't assume a dryer. Okay. All right, now let's talk about that cooking. Household cooking appliances. Let me make sure I'm still on the right screen. Yep. Okay. Household cooking appliances, ranges, wall-mounted ovens, counter-mounted cooking units, etc., are not required in a load calculation. Okay, they're not required, but of course they're included in ours, so we have to account for them because it is very much indeed a load. So if there is no cooking appliances rated over 1 3/4 kW, then there's no need to add anything to the calculation. However, we do in ours. We've got a counter-mounted cooking unit, a cooktop, at 7 kW, and we have a wall-mounted oven at 6 kW. Now both, again, are 240 volt sources. Now, individual household cooking appliances rated more than 1,750 watts or 7 3/4 kW, whatever, can be derated by using table 220.55 demand factors and all the applicable notes under table 220.55. Now, that's important to know, okay, because as you see here, our example is going to fall under column B within 220.55, the table. But there's some nuances I want to talk about in this. Now, again, the neutral load, again, whatever value here we calculate at, again, when you're doing the neutral, then you can take that value at 70%, just like you did the dryer, okay? All right, so let's kind of see what happens here. We have a 7 kW cooking, counter-mounted cooking unit. We saw that above, okay? And we have a 6 kW wall-mounted oven, as indicated in the calculation. Now, both units fall within the parameters of column B, okay, in 220.55. The demand factor percentage found in that column for 2 units is 65%. So I add the two together, okay, and I multiply it by the demand factor of 65%, which is going to give me 8.45 kW. Okay, that's a lot of words, but I want to look at the code. So here's the code. Here's where we're getting to the range. Here's where it tells you that I can use table 220.55 and all that. So let's look at table 220.55 right here. Again, always remember something when you're doing a calculation. Column C is to be used unless otherwise permitted by note 3. In order to use note 3, my household cooking appliances have to fall in the range, again, between 1 3/4 and 8 3/4. And that would be down here under note 3. And in note 3, it says, in lieu of the method provided in column C, it shall be permissible to add the nameplate ratings of all the household cooking appliances rated more than 1 3/4, but not more than 8 3/4. Okay? So in our case, what happened? They all fall under that application because we have a 7 and we have a 6. All right? So let's look at the table in the code and see how we derive. Now, if I were to just simply go and say I've got 2 appliances and the default is always column C, then I go over here and that's 11. Okay, now remember, this isn't a percentage. This is actually your maximum demand in kW, okay, which we're going to convert to VA, which is simply the synonymous. 11 kW is 11,000 watts, which is 11,000 VA. However, we can take the lesser of the two. So I can use column C, but I can also use, it permits me to use the note, and it's always the best possible choice on an exam. And since both of ours fall here, then that's where the note says that I just simply add them up, okay? And where they fall under both A and C, the demand factor for each column, they add it up. And if they fall under A and B, then I take each one of them separately by whatever. If it's 1, for example, then I would do it by the 80 and the other one by the 80. But both of ours all fall within this column. So it's 2 of them right here. And we're used to 65%. Now, when we did that, we're comparing that to the 11, right? So when we did that, obviously 8.45 kW or 8,450 is less than 11. So which am I going to use? I'm obviously using the 8,450 for my calculation, okay? Just remember, as this little, I guess it's right there, tip says right there, you want to remember that since the cooking falls under column C and B, be sure to compare the two and take the lesser of the two. Now, a shameless plug. If you don't know how to do all these different nuances with ranges, go to our website and watch the video. Or if you go to our website, click on the YouTube channel, watch our video on ranges and dryers, and you'll see how these things apply, especially the ranges. I go through all of the different concepts of doing that, okay? So don't overcomplicate it. In this case, they all fall under B. There's 2 of them. I'm going to be able to apply the 65%. It actually is less than what it would be in column C. Now, if you didn't remember to apply that, you would add them together and think that you got 13. Well, 13 is more than 11, so you end up taking 11, but you get the question wrong, okay? We get to apply because we're looking for the best obvious answer, and that's why we were able to apply the demand factors, and that's what we did here. So this is a value that's a hardcore value. You're going to take this value here, and you're going to put this aside and add it with your other ones as we move through, okay? All right. Make sure, yes. Okay, so now let's talk about the non-coincident loads. In our case, we have heating and we have the cooling. And we need to take these into consideration. Now, the beautiful thing about a single family dwelling or a individual dwelling unit is that we take the heat at 100% and we take the AC at 100% and we compare the two. When you're doing the optional method, you have some other allowances in there, and it's not complicated, and we'll cover that in another webinar, but it's a little different. But when it comes to the standard, I can just take the heat or the AC, compare them at 100%, and see which one is larger. Now, a couple things to remember here. And I'm using the heat, that if it goes to an air handler, obviously, that's going to blow the air around. So whether I'm in AC mode or I'm in heat mode, then it's going to actually, and this is electric space heating, okay, fixed electric space heating. So we're taking that at 100%, and that's what tells us that at 220.51 right there. We take it at 100, and we're taking the AC at 100, and we compare the two. So, but I want you just to remember that, see this air handler, it's got to blow that heat around, okay? And because it blows that heat around, I have to add that with the calculation when I'm doing the heat. So the air handler motor, and remember earlier when I said on an exam or in real life, when I start seeing these values here, I need VA. I need to have a VA value, okay? Well, with the electric heat, it's easy. It's 15 kW. I just convert that. We know that 15 kW equates to 15 kVA, which equates to 15,000 VA, so I'm done there. But what about that air handler? It's 3.2 amperes and 115 volts. Well, I don't have to go look up anything. I don't have to go to 430.248. I've got it right here. So, and on exam, you might not. It might just give you horsepower, and you got to do that little step that we did earlier. But here, I just take 3.2 amps times 115, and that's going to give us 368 VA. Okay, so I might jot that down so I don't forget that later. The next thing I want to look at is I've already got this air conditioning compressor, and I'm comparing the two, but in order to do that, I have to calculate it out. So it's 16.6 amperes times 230 volts. Again, I'm using what's given me in the actual question, and that gives me 3,818. That's right here. The next thing I have is this condenser fan motor, and that is 2 amperes. Again, 2 times 115, and that's going to give me what? 368. Okay, so we're calculating that out. All right, So actually, you know what? I'm going to take that back. I'm going to see if we're not wrong here on something because I saw something that doesn't look right. 3.2 times 115 equals 368. That was right. Now I'm going to take the 2 times 115. And actually, that's okay. I was right. It's 230. I went too far. Sorry, 230. So we had the 368 for the air handler. I was right. Sometimes I worry about at the last minute. All right, and then I had the 230, and that was the condenser fan motor. Okay, so this one is 368, this one is 3818, and this one right here is 230. Good deal. Now, I need to compare the heat versus the AC. All right, so the heat's pretty easy. It's 15,000, and we already know what the air handler is. That's 368, so I add that to this. So that would be 15,368. Well, it doesn't take us much to look and say, well, I can tell you right now that the heat is larger than the AC. So I get to omit the AC. The AC would be 3818 plus the air handler, which is 368, plus the 230. And again, that's going to come up to 4,416. That is nowhere near the 15, so I get to take the 15. Okay, so that was a hard number that we write down. You write that hard number down. Again, I'll give you a little tip. If you run into a heat pump scenario and it's got supplemental heat, that is not considered as a non-coincident load. You simply add the compressor's full load current to the maximum amount of the heat that can be energized while the compressor is running. And remember, include all associated motors and take all of that value into consideration, both the heat and the actual compressor full load current. Take those together, okay? Not like an optional method. You take those together fully. There's no non-coincidental issues going here. They're both going to potentially be going. Most certainly what's going to be going is that condenser fan motor, okay? So just remember that. This is for we're dealing with something that's fixed space heating and you have an air handler. They're probably separate units and you're trying to blow the heat around or you're also treating it separately for the air conditioning. Okay, all we're trying to do is give you the basics here. Again, if you have any questions on that, again, you can type your question down below in the little question thing and we'll answer it later. If you're using an optional method, it's much clearer in a heat pump where you take the AC at 100 and you take the heat at 65. Okay, a little different here for the standard method. We want to take the whole amount, all right? All right, so 15,368 is our value. Now, largest motor. This one most people forget at this point because it seems to not make that much of a difference because it's such a small amount. It's 25% of the largest motor, okay? So in our case, we had that in-sink waste disposal, and that was our 1125 VA, if you remember. We had our trash compactor, which was 900 VA. We have our attic fan. And remember, the largest motor only takes the one largest motor, not all of the attic fans, just one of the attic fans that you compare. And that was 4.2 amps times 120 volts, that's 504. So the largest here is the in-sink waste disposer. Now, some people ask me, why didn't you consider the dishwasher at 1200 VA? Well, you got to be real careful because the dishwasher usually has a motor, but it also has a heating, and the heating is the majority of the load. So the motor is usually pretty small. But just in case you're given that on an exam, look for the motors that they actually give you the values for. There's nothing that we can assume, okay? So the dishwasher, I'm not going to assume that's a motor load because it didn't give me that, but I am going to account for the load as an appliance. But I know that the motor is probably going to be significantly less than the half horsepower, but I don't know anyway otherwise. So for you guys in the real world, you need to know these values. Okay, if I happen to have some other motor load that was significantly larger, then I'm going to use that. Okay, now another thing to remember, we omitted the AC, right? We got rid of it. We're using the heat. If I had to use the AC or that had been the largest load, then the requirement under 220.50 refers us to 430.24 for the motors, and that's why we get that 25% on the motor. But also, it refers us to 440.6. So typically, the air conditioning compressor is going to be your largest, quote, motor, if you will, if you're including the AC as the larger between the heat and the AC. So since we omitted the AC, that's not the largest motor. We omit that, and we go looking for the next largest motor. And in this case, it was the waste disposal at 1127 VA. That's how we did it. And that's why we didn't calculate for the dishwasher, because we don't know the motor size. Okay. And I can promise you that the heating element in there is going to take up the majority of those loads. All right. So we took the in-waste disposal and we took this here at 1127 VA times 25%, because that's all we want. It's 25% of one motor, not all the motors, the one largest motor, and that equals 281.75. Remember that glorious 220.5B, where we get to actually drop the value of, or we have to round up the value. So in our case, it's 0.75. So it's greater than 0.5 and greater. So we're rounding up. So we drop this decimals here and we round it up to 282. That's another hard number. We write that down, okay? And 282 is the largest. Now, let's verify we covered everything. We got the outside dimensions. We took off the actual front porch. We took care of the 4 small appliances. We took care of the 2 laundries. We calculated the water heater in the appliance, the dishwasher. We calculated everything. We applied our demand factors to everything. And so now we're ready to do some math here. Now it's the crunch time. Remember these numbers I told you to write down? Well, the first one was at 7,048. And that includes what? The general lighting, the small appliance, and laundry. And we applied a demand factor to that in accordance with 220.42. So we did that. What about the fastened in place appliances? We did that. It was 4 or more. Okay. And we applied the 75% to it. So that's how we got the 6,929. What about that dryer? Well, it was at 5,500. We took it at that value. We had the cooking appliances. Remember that calculation we did? 8,450. And then we looked at the heat versus the AC. And we said that heat is much bigger than the AC. So get rid of the AC. I can use the heat. And so we took that, we omitted it, and it was 15,368. Lastly, we took that motor, and I say largest true motor because yes, the dishwasher had a motor, but nobody gave us any information. They just called it a dishwasher. I know that the heating element is probably the majority of the load there. And so just be careful when you're doing a calc. You really want to look at all the motors that are associated in there. But this was the largest for ours, and that was the in-waste disposer. Okay, add them all up. 7,048, 6,929, 5,500, 8,450, 15,368, and the 282. Don't forget that largest motor, although it probably won't make a difference in your overall calc. 43,577, that is our VA. Now, good old Ohm's law, we got to have the source voltage. In our case, is 240. And so it's 43,577 divided by 240. Going to give us 181.57. Well, we got that 0.5, so now we're going to round, okay? And that's going to round to 182 amperes, okay? That is what our actual calculated load is on this dwelling, 182 amperes, okay? Now, we have to determine the service. In our case, we're doing a service. We have to determine the minimum service amperage rating. Okay, since it was 182, we would go to table 240.6a, and you'll notice that I don't have anything for 182. I got a 175, so I'm going to choose a 200 amp device. Okay, now, if I choose that 200 amp device, I need to make sure that I choose a conductor that's going to at least handle 182 amps of the actual calculated load that we have that we're putting on this conductor based on our calculation. However, it can terminate on a 200 amp device as long as that calculated load doesn't exceed whatever the conductor size ampacity we choose. Boy, that's a lot of words. So let's look at it this way. I need a conductor that's good for 182 amperes. So let's go to the code. Now I'm going to show you something because I'm going to ask you to tell me on an exam, that's great, Paul, but what is the minimum service rating I need, and what's the minimum size service conductors I need permitted by the code? All right, so let's go to the code book really quick. And we're doing this calculation right here. And what I want to do now is go to 31015B16. That's our ampacity tables. Bear with me. I probably should have had it queued up, but I didn't. That's why we're live. And let's go right here. All right, so I'm dealing with what? let's kind of recap what we did. I've got 182 amperes. I gotta have a conductor that at least gives me the 182 amperes. Then I can determine whether I can terminate that on a 200 amp device. And as long as my load doesn't exceed, and we know my load right now is 182. Okay, I calculated that. So let's go look here. So if I go down here, I'm going to choose column C because we didn't tell you anything otherwise about terminals. But again, I'm going to give you a little hint. If you look at 110.14c, if you're dealing with 100 amps or less, or over 100 amps, we're going to do 75. Under 100 amps, we're going to be 60. We're obviously over 100 amps, so we're going to be into 75 degrees C. Okay, most exams are going to give you that value, but just want to kind of tell you where we're at. All right, so if you look here in the code, I'm going to need 182, and so, wow, it looks like I'm going to need a 3-aught. All right, and so if in real life, that would be okay. And we always assume copper unless they express otherwise. In real life, I'd be all right. But if I ask you what the minimum size, oh, and by the way, the 182, that conductor is good for 200 amps. If it was a 3-aught, obviously I can have 182 amps on a 3-aught because it's good for 200 amps and I'm not going to have any problem. All right. But I ask you to do the minimum. Now we know this is a single family dwelling. And if it's a 122.40 volt, we have another calculation that we can use. And that is 310.15 B7. And on an exam, if they ask you and they tell you it's 122.40 and it's a 3-wire single phase, then you need to know that it results in the smallest service conductors and the smallest service that I want to be able to size those conductors based on 310.15 B7. Okay, so we're going to look at that real quick in the code. And I'm going to go back here so you can see it. And here we are right here. So if our dwelling service, and it also applies to feeders, but in our case, we're going to do, we're just doing services. If it is a one family dwelling, okay, and it's a single phase, 122.40 volt, and it is, shall be permitted to size in accordance with 310.15 B7.1. And now we're using that because we're dealing with a service. Now, our service indeed was between 1 and 400. We said it was a 200. And we have to make sure that the panel or the service applies the entire load. Okay, what are we talking about there? All right, and we're rapidly running out of time. Is that it's going to handle 100% of the load. Okay, all right. What do I mean by that? Okay, well, let's look at the presentation here real quick. Is that, and I got a drawing right here. So here's the panel. Kind of jump back and forth here because I'm running out of time. Here's the power coming through the meter, and it's going. So this one here, these conductors right here are handling 100% of the load. Okay, then I can utilize 310.15 B7. And in this case, what it tells me is that I can take these conductors, the minimum size that they would have to be is 83% of whatever the service rating is. And we determined this was 200 amps. So 200 times 0.83 is 166 amps. So these conductors right here have to be at least sized to handle 166 amperes. Okay. Now, if you remember, there used to be a little mini table in the code, and it's still in there. It's been informative annex D. In the 2020 code, it actually comes back here, but of course we redid the entire 310 in the 2020 code. It's going to look totally different. Kind of says the same thing, but it looks a little different. So get used to that. You're used to all these 310.15 B17, 16, all that. It's all going to change, but don't worry about it. It's easy. But that's what it's talking about. All right. Now, same here. If I've got the meter here and the power's coming in and I have the service disconnect here because I want to have the panel further into the building, then as long as these conductors right here, these feeders, are seeing 100% of the load, then I can size these as well to the 83% of the feeder rating, whichever the rating is here. Okay, if this was a 200 times 83% is 166. Okay, so I have to do that. So sizing conductors. Now, if this was a panel like this one here, and I was dumping out of here to feed some air conditioning units right here, and then it was continuing on, like maybe a feed-through panel or something, then are these feeders seeing 100% of the load? Absolutely not, because some of the load is coming off right here. Then I could not apply 310.15 B7 here. I'd have to take these at the full value in 310.15 B16, okay? All right. So remembering though, these feeder conductors never have to be larger than what the service conductors would be. Okay. Again, if you're confused about this kind of thing, then go watch my derating demystified video. It's free. It's about an hour and a half, I guess what it is or so. It might be longer. And it'll teach you everything you need to know about derating, adjustments, corrections, and all that good stuff in there. Okay. All right, so we know what conductor size we have to choose because now we're going to say, well, I got 166. So let me go back to the code book and say, well, I got to find something that's going to handle 166. Well, if I come in here, then I see that, well, wait a minute, a 2-aught can handle. So before it was a 3-aught, but now it's letting me do a 2-aught. And that's where that old table was derived from. So that's 175 amperes. So I can use a 2-aught copper or a 4-aught aluminum if I'm going to utilize 31015B7, okay? But that is going to result in your smallest size conductor. And it's all based on the service rating or the feeder rating. And that, again, is based on this device. Well, hold on. Let me get back to where I'm at. This device right here or this device right here. That's what those are going to be based on, okay? All right, so as you see here, if the code question asks you on the exam, what is the minimum size feeder service rating? And that was 200 amperes. And we had to do the 83% to find the 166 amperes for the conductor. We saw how we calculated the service rating, and we have to know that in order to be able to apply the 83%. Now, in the real world, do I have to use this? No. If you want to size the conductors larger, go for it. But you're not required to, okay? It's permissible to do this, and most exams are going to want you to do this. And again, it results in the smallest service, and again, smaller conductors, and that saves you money. Okay, it's all about the money. Now, how do you size the grounding electrode conductor? Once you know the size of the conductors, then you guys know that at that point you go to 250.66 based on the 2-aught copper. You go there. Since we're asking about a water pipe ground, you go over to the table, you go down. I was going to do that, but I don't want to take our time up for doing that. All right. Now let's talk about neutral loads, and I might run over the 1 hour, but that's okay. You can tune out anytime you want. If you want to quit after 1 hour, that's fine. But now we're going to talk about the neutral. Now the neutral has to be calculated, okay? Has to be calculated based on the standard method. It cannot be calculated based on the optional method, okay? So in our calculation here, we're going to take all of the values that were 120 or even the ones that are expressed as 115. So all of these branch circuit applications where we're calculating the load for the small appliance, for the laundry, for the dimensions, all of those are normal receptacles. They're normal lighting. So they're 120 volt loads. So I'm going to take that value. The good news is you've already done that calculation. And all those demand factors we applied, the first 3,000 at 100 and the remainder up to 117,000 at 35%, all of that still applies. So I don't have to redo the math. But if I was doing an optional method only, I got to go back and do the standard method in order to be able to come up with this neutral. All right, so we're going to use that. We're going to use all of these appliances because they are 120s or 115s. Okay, they all have a neutral load, if you will. None of these are going to be considered because all of these are 240, except we are considering the dryer and the cooking when it comes to that 70%. Okay, so the reason I didn't gray them out is because I'm only going to show you the 115s. But yes, we do have a neutral component, and we'll look at that here in a second. The heat, we don't, because that's pure 240. The air handler, again, is 115 volts, and the condenser is 115 volts, so very much comes into play when we're sizing the neutral. All right? All right, so remember this calculation we did earlier with that demand factor, and it came up to 7,048? Then we take that number, that counts. We count that. So that's your first neutral calculation, okay? The next thing is remember those appliances. Well, as you see here, I don't have to count the water heater, but I do have to count all of these. So that was 1,200 VA for the dishwasher. That was 1,127 for this disposer. That was 900 for the trash compactor. And remember I had 3 Addicts fans? Well, I got 3 of them. So that's 1,512 for all 3 of them. That's where I got the 12.6 amps, is because I added all 3 together. Okay, add that up, it's 4,739. Okay, now, do I have 4 appliances still, or 4 or more? Absolutely, I do. Absolutely. Okay, I got 3, 4, 5, 6 actually. So is this 4 right? No, I got 1, 2, 3, 4, 5, 6. Okay, I usually put this in there, make sure somebody doesn't get it wrong and a mistake. If I didn't have a trash compactor and I only had this like this, somebody might read this as 1, 2, 3 and say, nope, you can't apply the 75% because they forget that there's 3 of them here. That's kind of why I do it. All right, so I can apply 75%. So it was 4,739 VA times 75% or 0.75, however you like to do your math. And that is 3,554.25. Well, guess what? I get to drop that 0.25. So it's 3,554 VA. Write that down. That's the number you write down. The next number I got to consider. What about that dryer? Well, remember what it said? That I can actually take that at 70%. If you're asking me, yeah, Paul, I remember that, but where did I see it? Well, you saw it in 220.61b. So we're going to go look at that. So in 220.61b, I just want to show you where it gives us that ability to do that. And we're going to go back up here. And should be real close here, right here. All right. It says right here, permitted reductions. It says, notice it says, for a service or feeder supplying the following loads shall be permitted to have an additional factor of 70% applied to the amount in 220.61b1 or a portion in b2. Now, b2 is when we're dealing those applications where the neutral has a calculated value over 200 and we get to apply something here, that 70% to that value that's over 200. You're not going to worry about that for dwellings. That's for like commercial applications, and we'll cover that in a non-dwelling unit podcast. Trust me. But here we are most certainly going to use B1, and it says what right here? We're dealing with the dryer and our range and our oven and our cooktop. All of those get to apply the 70% to the value that we calculated when we did the standard method. All right. So let's kind of go back to the presentation. And so I did that here. 5,500 times 70% or 0.70, however you want to do that. That's 3,850 VA. All right, so I add that. That's a hard number. You write that down. The next is the cooktops and the wall-mounted oven. Now remember how we did it earlier and we came up with the 8.45 kW? All right, well, we take that value. We've already done these. That's the beauty of this. If you do the standard method first and you do it, then you get the beauty of being able to do that. Nope, my alarm came off. It says I'm at 3, so we are at 3. So I got pretty close, but we're going to keep going because I want to make sure I cover all this. Okay, trust me, it's only a couple more minutes. All right, so when I'm dealing with this, I take the range calculation. We did this earlier, and we do that at 70%, and that is 5,915. Okay, that's another hard number. I write that down. Okay, now. Next, we need to move on to the AC versus heat because we already kind of did that for when we did the calculating, but we need to look at them when it considered dealing with the 115 or 120 volt loads because they're very much going to come into play. Now, here's the neat thing. That air handler and that condenser fan motor are going to run simultaneously, okay? Whether or not I'm using an air handler, they're going to, different times they're going to run, so I have to count them both, okay? So, remember it was 230 VA. That is a 115 volt, so I count that. That's 230 VA. But then I also have the condenser motor at 2 amperes at 115. Again, if you don't remember anything, remember that both of these are 115s. Go on and count them for the neutral. Okay? So in this case, 230 plus 368 is 598. Okay? So I add those two. All we're doing is going down the list and trying to accommodate all of our potential neutral loads and accounting for those. All right, now, the one thing that many people forget, again, and it happens, is that largest motor, especially the one that's connected to a 115 or 200 volt load. That's what we're trying to calculate for here. Now, if you forget this, it's probably not going to make or break your calculation because we're talking about a really small amount, okay? The only time that might make or break something is if it was near the point where you're going to round it up or round it down. And then at the end of the day, it's probably only going to swing you, if anything, 1 amp, maybe, if that. So it's not going to make a whole lot of difference. But I want you to know that you have to consider the largest load, motor load, whether or not you're dealing with the actual standard calculation or you're doing the neutral using the standard calculation, because you can't use the optional for a neutral load calculation. All right. So we want to find the largest motor. Well, in-sink waste disposal was our largest motor. Remember, at 1127. Again, we don't use the dishwasher. Why? Because we don't know the motor's value, and we know that there's a lot of heating loads in there. For our calculation, they didn't give us the motor for that. Now, if you get a question on your exam that gives you the dishwasher and it tells you what the motor is, and then it gives you the overall load, that should let you know that you got to factor in that motor. And it's might be the largest motor, but in our case, it did not. So don't overthink it. And so in this case, 1127 VA is our largest motor, and I simply take that as 25%. Remember, we already did that before anyway. Okay, so 1127 VA times 0.25, and that's going to be 281.71. Remember that 0.72? Excuse me, I said 281.72. What are we doing with it? Rounding up. So it's 282. You write that down. That's the next one you write down. All right, did we cover everything in here? It looks like we covered everything for our neutral. We definitely covered the dishwasher. We covered all these motors. Basically, I kind of checked off our list, all these 115 and 120 things. We're good to go. Let's see, did we get that trash compactor? Absolutely. We got it all. All right, now, what did we do before? We just got to add them up now. So, the 7,048, the 3,554, which is what the fasten in place ones were. The dryer at 5,500 VA times 70%, that was 3,850. The cooking, which was 8450 times 70%. Remember, we got that allowance to do that in 220.61. And that is 5915. And then, of course, we had that air handler motor and that condenser fan motor. Both of them were 115. And so we added them together, and that's how we got that 598. And, of course, we had to select that largest motor, which most people forget to do. But, again, that's only 282 VA. Probably not going to make a big difference. But in the real world, adding it up, I want to make sure I know to do it. Me and you want to make sure we get it right. So 7,048, 3,554, 3,850, 5,915, 598, and 298 is going to be 21,247 VA. Again, using Ohm's law, we're going to divide that by our source voltage. In this case, was 122.40, and that's going to be 21,247 divided by 240. Is 88.52. Well, we got that 0.5, so what are we going to do? We're going to round it up. So that is 89 amperes. So I now have to find a conductor that is going to handle 89 amperes. Okay, that is our imbalance load. So 89 amperes, I've already rounded it. So I would go to 31015B16 and have to find a conductor that can handle 89 amps. And of course, we go a 3-gauge copper can handle 89 amps. In fact, we'll just verify that. Okay, I'll go on and do that before we round this thing totally out because we are almost done. I hate going over because it takes your time, and I know your time is valuable. And again, I apologize. I didn't time it very well, or I probably gave you more information than I was originally going to do. All right, so here we needed what? 89 amps? Well, we just missed the 4, but we have a 3. It's going to give us 100 amps. And over here in the aluminum, we're going to be under that value there. Oh, we got a 90. It's perfectly fine for that application. All right, for the neutral. Okay. All right, let's come back and see what we got. So that should wrap up that. So what I'm going to do, sorry about that. I went to blank screen, back to me. Doing a standard calculation is really just that simple. Methodically go through each item. Okay. And don't make it overly complicated. Again, as always, this is just the very basics of the calculation. If you have any additional questions, man, you can always reach out to me. I don't know it all, but I try to do what I can to teach as many people around the country as I can. We get over 300,000 unique views to our websites and our videos and our podcasts. Hope you listen to them right here on the link. Go to the website. We're going to have another webinar that we're going to talk about the optional method, and I will post that, and hopefully you are interested in that. If you want to know about it, just send me an email at info at masterthenec.com, and down in the where you give the comments in it, or where you put the body, just simply put, Paul, sign me up for the optional class. And I'll make sure that you're included in the list, and I'll make sure you get an email. You're going to log in the same way as you did today. Okay, you're going to go right to my webinar page. Hopefully this worked and didn't delay or drop. And if it did, I apologize. It's the best I can do. I don't see where I dropped anything, and it's still recording. So hopefully everything worked good. So guys, until next time, hopefully you got something out of it. Hopefully I didn't talk too quick. Okay, but go watch our videos. We've got tons of them on it. Till next time, folks. I was only 10 minutes over. So stay safe and God bless.